Ashe. I am your royal narrator, Queen Magical Melanin, extending a warm greeting to all gathered for our basic applied electronics information session produced by our esteemed elder Baba Jelani Bomani Dembe, the brilliant mind behind Majestic Mind Matters University and the mandatory Mental Liberation series, eagerly enriching our learning journey. Today, we venture into the world of basic applied electronics, where circuits and currents intertwine to unlock endless possibilities. Let us embark on this enlightening adventure together, exploring the wonders of technology and innovation under the guidance of our distinguished elder Baba Jelani Bomani Dembe. Welcome to a transformative experience that will ignite your curiosity and mastery in the field of applied electronics. So pay close attention and take plenty of notes to prepare you for possibly answering a few easy questions near the end of the session. In this basic applied electronic information session, you will be introduced to the antenna. Antennas are a crucial component in the field of applied electronics, as they are responsible for transmitting and receiving electromagnetic waves. As such, it is imperative for applied electronics technicians to have a comprehensive understanding of antennas in order to design, install, and troubleshoot electronic systems effectively. In this essay, we will explore the key concepts that applied electronics technicians need to know about antennas. First and foremost, technicians must have a solid understanding of the basic principles of antenna operation. Antennas work by converting electrical signals into electromagnetic waves and vice versa. This process involves the movement of electric current along the antenna's length, generating an electromagnetic field that propagates through space. By manipulating the shape and size of the antenna, technicians can control how the electromagnetic waves are transmitted and received. One of the most important parameters to consider when designing or using antennas is their frequency response. Antennas are typically optimized for a specific range of frequencies, known as the operating frequency. In order to ensure efficient transmission and reception of signals, technicians must carefully match the antenna's frequency response to the frequency of the signal being transmitted or received. Additionally, technicians must be familiar with the different types of antennas commonly used in electronic systems. Some common types include dipole antennas, monopole antennas, parabolic antennas, and Yagi antennas, each with its own set of advantages and disadvantages. Understanding the characteristics of these different types of antennas is essential for selecting the best antenna for a given application. Furthermore, technicians must also be knowledgeable about antenna polarization. Antennas can be vertically polarized, horizontally polarized, or circularly polarized, with each type of polarization affecting the way in which electromagnetic waves are transmitted and received. It is important for technicians to understand how antenna polarization can impact the performance of an electronic system and how to properly orient antennas to achieve optimal signal reception. In addition to these fundamental concepts, applied electronics technicians must also be familiar with the practical aspects of antenna installation and maintenance. Proper installation of antennas is essential for maximizing their performance and ensuring reliable communication. Technicians must consider factors such as antenna height, orientation, and interference from nearby structures when installing antennas to achieve optimal signal coverage. Furthermore, technicians must be able to troubleshoot common issues that may arise with antennas, such as poor signal strength, interference, or damage to the antenna itself. By understanding the underlying principles of antenna operation and the factors that can affect antenna performance, technicians can effectively diagnose and resolve these issues to ensure that electronic systems continue to operate smoothly. Antennas are a critical component in the field of applied electronics, playing a key role in the transmission and reception of electromagnetic waves. To be successful in their work, applied electronics technicians must have a thorough understanding of antenna principles, types, frequency response, polarization, installation, and maintenance. By mastering these concepts, technicians can design, install, and troubleshoot electronic systems with confidence, ensuring reliable communication and optimal performance. In the field of applied electronics, understanding the different types of antennas and how they affect signal strength and reception quality is crucial for technicians to effectively design and implement communication systems. Antennas are essential components of wireless communication systems, and their performance can have a significant impact on the overall performance of the system. One of the key factors that technicians must consider when selecting an antenna is its directionality. Directional antennas, as the name suggests, focus their signal in one specific direction. This can be advantageous in situations where the signal needs to be concentrated in a particular area, such as in point-to-point communication or in environments with obstacles that block signals from other directions. By concentrating the signal in one direction, directional antennas can achieve stronger signal strength in that direction compared to omnidirectional antennas. On the other hand, omnidirectional antennas transmit and receive signals in all directions equally. While this can provide consistent signal strength in all directions, it may not have the same level of signal strength as a directional antenna in a specific direction. Omnidirectional antennas are often used in applications where signals need to be broadcast in all directions, such as in wireless networks or broadcasting systems. Yagi antennas are another type of antenna that technicians may encounter in their work. Yagi antennas are designed with multiple elements that are arranged in a specific configuration to enhance signal strength in a particular direction while reducing interference from other directions. This makes Yagi antennas ideal for point-to-point communication or for use in environments with high levels of interference. By focusing the signal in a specific direction, Yagi antennas can improve signal strength and reception quality in the targeted direction. Dipole antennas are simple antennas that consist of two conducting elements. While they may not provide as strong of a signal as other types of antennas, dipole antennas are easy to set up and can be effective for short-range communication applications. Dipole antennas are commonly used in applications where a low-cost, simple antenna design is sufficient, such as in home wireless routers or radio receivers. In addition to understanding the different types of antennas, technicians must also consider other factors that can affect signal strength and reception quality. These include antenna placement, height, and orientation, as well as the surrounding environment and any sources of interference. By carefully considering these factors and selecting the appropriate antenna type for the specific application, technicians can optimize the performance of communication systems and ensure reliable signal strength and reception quality. Technicians play a vital role in the operation and maintenance of antennas, which are crucial components of communication systems. In order to effectively perform their duties, technicians must have a solid understanding of the basic principles of antenna operation. Antennas work by converting electrical signals into electromagnetic waves and vice versa. This process involves the movement of electric current along the antenna's length, generating an electromagnetic field that propagates through space. By manipulating the shape and size of the antenna, technicians can control how the electromagnetic waves are transmitted and received. One of the fundamental principles of antenna operation is resonance. When an antenna is operating at its resonant frequency, it is able to efficiently convert electrical signals into electromagnetic waves. Resonance occurs when the length of the antenna is equal to or a multiple of the wavelength of the signal being transmitted. In order to achieve resonance, technicians must carefully design and construct antennas with the appropriate dimensions and materials. Another important aspect of antenna operation is radiation pattern. The radiation pattern of an antenna describes how electromagnetic waves are transmitted and received in different directions. By adjusting the shape and size of the antenna elements, technicians can control the radiation pattern to focus the signal in a specific direction or to achieve omnidirectional coverage. Understanding radiation patterns is crucial for optimizing the performance of communication systems and ensuring reliable signal transmission. Polarization is another key concept in antenna operation. Polarization refers to the orientation of the electric and magnetic fields of an electromagnetic wave. Antennas can be polarized horizontally, vertically, or at an angle depending on the orientation of the antenna elements. Matching the polarization of the transmitting and receiving antennas is essential for maximizing signal strength and minimizing interference. Technicians must carefully align the polarization of antennas to ensure efficient communication. Impedance matching is also a critical aspect of antenna operation. Impedance matching ensures that the antenna is properly matched to the transmission line and the load, allowing for efficient transfer of electrical signals. When the impedance of the antenna does not match the impedance of the transmission line, power loss and signal reflections can occur, leading to poor system performance. Technicians must carefully adjust the impedance of the antenna using matching networks and tuners to optimize signal transmission. In addition to the basic principles of antenna operation, technicians must also be knowledgeable about different types of antennas and their applications. There are various types of antennas, such as dipole antennas, loop antennas, horn antennas, and parabolic antennas, each with its own unique characteristics and performance capabilities. Technicians must understand the advantages and limitations of each type of antenna in order to select the most appropriate antenna for a specific application. Furthermore, technicians must be proficient in troubleshooting and diagnosing antenna problems. Antennas can experience a variety of issues, such as cable damage, water ingress, corrosion, and mechanical failures, which can impact the performance of the communication system. Technicians must have the skills and expertise to accurately diagnose antenna problems and implement effective solutions to restore optimal system operation. In conclusion, technicians play a crucial role in the operation and maintenance of antennas. In order to perform their duties effectively, technicians must have a solid understanding of the basic principles of antenna operation, including resonance, radiation pattern, polarization, impedance matching, and antenna types. By possessing a comprehensive knowledge of antenna operation, technicians can ensure the reliable and efficient operation of communication systems. Applied electronics technicians must have a solid understanding of the different types of antennas and how they affect signal strength and reception quality. By carefully considering factors such as directionality, antenna type, placement, and environmental conditions, technicians can design and implement robust communication systems that meet the needs of their clients and end users. Choosing the right antenna for the job is essential for achieving optimal performance and ensuring reliable communication in a variety of applications. Thanks for your participation in this majestic Mind Matters University Basic Applied Electronics Information session titled Introduction to the Antenna. Ashe.